Python-based platform for seasonal adjustment of economic time series. And without hesitation, the floor is yours. Please go ahead.
So, hello everyone. Can you see my screen, right? I think.
Yes, we can.
Okay. Good afternoon, everyone, from my time. So I'm LijingSun from U.S. Census Bureau. Today, I will present and demonstrate Python-based platform for seasonal adjustment of economic time series. First of all, a little bit of background. As you know, X13 ARIMA software, C software is produced, maintained, and distributed by U.S. Census Bureau. And the latest version is Build 61, which was just released this July. And then the software is written in Fortran, but we face some some challenge. For example, it's hard to hire a Fortran programmer, and Fortran doesn't provide interface capabilities, and moreover is very difficult to incorporate new technology and the methodology into the existing ones. So we have been developing a new platform called Session1, formerly we call PyX13. So we choose Python as our software development language. In this new platform provide a user-friendly GUI interface. Also, you can run in the command line. We reuse some proven Fortran modules because they are stable. The beta window version was released last year for some internal and external users, and we are currently testing our beta Linux version. Today, I will demonstrate the GA version, but this GA version is still currently in development and is not fully tested. And we plan to release next year. So in this GA version, it can load more different time series data files types, such as you can load like any plain text, CSV files, and then you can load the data from the Excel files too. It includes additional capabilities for seasonal adjustment, such as a tool to calculate X11 symmetric filter rates, and then a tool to generate user-defined moving holiday regressors. It's called GenHaul. And we also add a new methodology called reg component. GenHaul and then reg component will talk separately. So let's do the demo. So once you start our application, this is our landing page. So you can choose from these three different methods. One is called X13 ARIMA spec mode. The other is batch mode, X13 batch mode, and then reg component. So the spec mode means that you work with one single spec file at a time, and the batch mode you work like multiple spec files same time and run them together. So let me start with single spec mode. So once you start it, this is the spec mode interface. On the top are the menus. Under each menu lists some functions, and there are three major panels here. On the top left is a spec list panel. So we keep the same input files we call spec files in order to run the X13 Fortran version. So we keep all the same input files, and then in the spec list, it lists all the available specs in X13, and then inside each spec, it has all the available arguments in it. And then this is the on the right is the output panel. At the bottom is a console panel. So there are three ways to work with single files. One, if you already have existing ones. The other one you want to create from scratch. And the third way is you create a spec file from Wizard. So let me open existing ones. So this is the airline model everyone familiar with. Once it's loaded, it do some validations. If there's some error, it will show in the console. And then you will see the content in the spec will displayed in the output panel labeled spec text. Also, you can view the original time series graphs. In the meantime, all the select specs are checked in the spec list, and all the value associated with the argument in the spec file are populated. You can edit, make some change either by in the big spec list or you directly write into this spec text panel. We also build in some validations into the for some arguments. For example, I've just typed something wrong for the period. The error message will show up, and then after you acknowledge that, the value will be shown in red and in the spec text. And then when you go back to the spec list for this argument, it will show in red background. And then you can just, once you change back, it's become, it's normal. So once you are ready, you can just validate the whole spec to see if there are any errors. If there are some errors, it will show in the console. If they are not, so I'm ready to run this spec. So you also can set some option flags like you set in the X13 Fortran version in the command line. So we have the G flag, T, N flag, T flag, Q flag. So let me just run in a graph mode. So I need to find a place to save all the output files for this graph mode, generated by this graph mode. So after I select, I'm ready to run. So once you run it, we keep all the output files which are the same as the X13 Fortran version, and then displayed some of the output files in the output panel. So you will see this is the main output file, this is the log files, this is will show you some error message if you have and notice. And then if you have some save argument in your spec, or you run like me in the ggraph table, and then both table and the graph tab are show up. In the tables, you can view different tables one by at the same time by the different categories. So they have ACF, you can view this index by leg. And the same thing as the graphs, you can view like overlays, you can see the, and then you can view like forecast only. So this is the output panel, and then you'll notice a new row is inserted into the summary diagnosed panel. So in this row, it will give the information of the model adjustment and then diagnose informations. These informations are displayed in 6 different categories, and also this row is color coded. So in my example, this is pink. That means at least one diagnosed field based on what the threshold you set. So in my example, I have 3 columns, 3 diagnosed that field. So if you go to that column, the SIG, for example, SIG ACF, it is in bold. If there's no fillers but some warnings, the row will be showing in yellow, and then if it's no filler, no warnings, it will show in gray. So in my case, I also have some warning diagnosis, like for example, holidays. So it will be shown in athletic. So we also build a tool to display X11 filter weights for estimates of the various components. Like seasonal, irregular, etc. So since I have this of X11 final result based on the seasonal filter from D5, D10 table, Hansen filter from D7, D12 table, also it's definitely based on the period. So since I currently have a spec run, so it will set the default value as it from this current runs, like 3x7, 3x3. And then you also, both tables and then graphs will be shown here. So you can view by choose a different field type, and both tables and the graph will be can be saved for your later reference. So that's X11 filter. Also, you can we have another functionalities like user settings. So for user settings, you can decide, you can choose what when you rerun the spec, what you want to override the current one, or you want to rename the current one. Or you can set a default graphic directory to save all the graph generated output from.
5 minutes to go.
Oh, okay. Okay, so the set the threshold. There is a function set the threshold. So you can set the threshold as you want to select to the new one. So next time when you run it, so I rerun this. Next time you run this, that's it will the threshold will the filler you see is gone because I deselect the 3 like 3. So this is open existing ones. So you can do this from the spec file, create by a scratch. And then the wizard, you can create spec file from wizard. So this is the default spec file will displayed, and then you can just choose different date files. You can tell us which time series data you want to work on. And also I want to mention there are 6 tabs you can put different informations. I want to mention one is like we have a recommend transform text box here. For example, the transform is auto, but if you check this box, the X13 will run, and then the system will grab the X13 choice and then hard code it in here. So you see my function change to log. So this is the single spec, work with the single spec. There's another, let me switch to batch mode. So to work with a batch mode, there are several ways too. So you can load a batch run. That means you loop each individual and run each individual separately. And then if you have a composite, you can just you can run as a meta files, and then you can load many spec files together, and then load many data files, and then run a single spec. So let me show you I have a meta file. So this is the bright meta file I have once you load it. So the meta file is displayed here. When you expand it, this lists all the specs here. The last one is a composite. So it's the same way you can, once you're ready, you can just run the spec mode. You can just run this meta file together. Sorry. Let me run it, and then it will populate this diagnose panel will populate with a row for each of the specs, giving the same information as I show you in the spec mode. I'll provide you the model adjustment diagnose information and also color coded. There's an additional tab here in direct diagnostic. It only shows as the composite diagnostic. So if you want to work and take a look at each individual ones, sorry, I don't want to save it. And then if you go back here, and then you can make some changes, and then you run it. So when you go back here, it will detect the change and then ask you if you want to reflect the change. So if you want to reflect the change, this will be reflect the new changes here. Another thing I want to show you, you can load different many data files and then create data files, create spec files for each of the time series. So like for example, I have 2 these ones. I want to create each one for this type spec for each of them. So I can go here to click a spec file for each series. So this is the default ones. So you can put since it's data file, I need to put the format, and then I tell me it's a monthly and quarterly data. And then we also have add recommendations here. It's set to the same rules, the same business rules. Once I show you in the wizard, you can just want X13 run and then pick up the choice for you and hard code in your spec. So I just want, you can dislike some of them if you don't want, and then you can just click this button to create a different, create a spec for each time series. So when you go back here to
One
look
minute,
at the new,
one
okay, yeah,
minute to go,
almost,
please.
yeah. So thank you. So you see, since I add the recommendation, so this is the log. My function changed to log, and then my ARIMA has been chosen for me like this. There are some other functions like you can save batch runs for later use, and you can create composite meta files. So that's pretty much of the my demo. So if you have any questions, this is my, you can send me email. I'll send our team an email. We are very happy to answer you. Thank you.
Okay, thank you very much.